session we shall simplify rational expressions. Please, before you view this video, it is highly recommended that you view the videos on factoring. Please, all the videos we did on factoring, the entire videos in the video playlist on factoring, it is important that you view it before you view this. Let's talk about rational expressions. When we talk about rational, rational expressions. So rational. So we see that it's like a ratio, and when we talk about a ratio, we are talking about a quotient. If you can recall and it is good if you view that video on videos we did on numbers. With a rational number, we say that if it can be expressed as for a rational number, right? We see that it's expressed as a P over Q. Okay, P over Q, where Q is not equal to 0. Q is not equal to 0. Okay, with a rational expression, we now talk about algebra. We can say it is a quotient. Okay, quotient of two polynomials. Okay, and whereby the Q of x is not going to be equal to 0. So whenever we talk of a rational expression, we don't want the denominator. It's a quotient, it's a ratio. So it's a division, it's a quotient, it's a fraction. Okay, and we don't want the denominator to be equal to 0. Why do we say that? Because if the denominator is equal to 0, that will make the expression to be undefined. So we are going to simplify rational expressions in this video, and we need to look at just a simple definition of this rational expression. Is simply defined as a quotient of two polynomials. Okay, a quotient of two polynomials where the denominator is not equal to 0. Now, in this video, before we simplify the rational expressions, we want to use all the methods of factoring that we have gone over, and we will kind of list it here. We will kind of list all the methods here of the factoring. Number one, we have a factoring by GCF, factor by GCF. Of course, that is the most important one. Like we mentioned in previous videos, you want to first of all try factoring by GCF first. Number two, we have a factoring by grouping, factor by grouping. Number three, we have a factor by a difference of two squares, Okay. Number four, we have a factor by a difference of two cubes, Number five, we have factor by sum of two cubes. Number six, factor by factor quadratic trinomial. trinomials. Number 7, factor quartic trinomials. Factor quartic trinomials. So this is what we're going to look at, and we will use these methods to simplify the rational expressions. Let's get started. So let's start with question 1. Question 1, negative 30 p squared q squared r squared over negative 35 p r cubed. Well, this one is pretty straightforward. This one is just a division of polynomials, and that is just this one. It's just division of polynomials. Okay, so but it's still a rational expression, but it is just division of two monomials, which we did. We have done it on the videos on polynomials. So we can kind of, like I teach my students, dissociate, then divide, then associate. So this is a negative 30 times p times p times q times q times r times r. I mean, this is the long way. I mean, you could just look at it immediately and say the answer. But if you really want to break it down, you could do this. Negative 35 times p times r times r times r. So, of course, negative divided negative is positive. 5 into 30 will give 6. 5 into 35 is 7. P will cancel P. Then R cancels R. R cancels R. So, do you have any other thing that will cross out? No. So you have 6 P Q squared. You now associate. 6pq squared over 7r. And this becomes your answer. But this is kind of the long way. Some folks won't do it this way. Some folks will simply come and they will do of course, they'll go ahead, negative divided by negative is positive. You want to do the signs first. Okay, do the signs first. Then 30 and 35. 5 divided 30 is 6. 5 divided 35 is 7. Times p squared, p, then 2 minus 1. From law of exponents. Now, q does not have any brother at the denominator, so you just write q squared times r, 2 minus 3. So this becomes 6 over 7 times p times q squared times r to negative 1. Okay, because 2 minus 3 is negative 1. So this becomes 6pq squared over 7 times 1 over r1, which is now 6pq squared over 7r. So the same thing, I mean, whatever you want to do, whichever way you want to solve it, that's fine. Okay? Now let's do question 2. With question 2, we have mn plus n squared over m squared minus n squared. So we look at the denominator. We see we can do what? Factor by GCF. Like I said, you've got to look at it and see whether you can use any of these. So we look at the numerator, not the denominator. We look at the numerator, we see we can factor by GCF. What is the GCF? Is n. What is remaining? n plus n. Okay? Over m squared minus n squared. This is the difference of two squares. And with difference of two squares, it is m plus n times m minus n. So this will cross out, and the answer becomes n over m minus n. And this becomes your answer. N over m minus n. And it's question 2. We do question 3. 20k plus 50 over 15k minus 30. Right? We look at the numerator, we can factor by GCF. What is the GCF? 10. So this is 10k 2k plus 5 over, we look at the denominator, we can factor by GCF. What is the GCF? 15. 15k minus 2. Okay? 2k plus 5, then k minus 2. Now, we can now divide. 5 going into 10 is 2. 5 divided 15 is what? 3. So this becomes 2 times 2k plus 5 over 3 times k minus 2. Okay? Can you cancel anything more? You cannot. You cannot simplify further. So you leave your answer like this. Always leave your answer as a factored form. Okay? Leave your answer as a factored form. This becomes your answer. Question 4. We have a 12x squared plus 11x minus 15 all over 20x squared minus 23x plus 6. Okay, when we look at question 4, the numerator is a quadratic trinomial. And then the denominator is also a quadratic trinomial. So, let's see whether we can factor it, okay? We look at the numerator. Can we factor first by GCF to make it simpler? We cannot. It's 12, 11, 15. So, we just go ahead and multiply 12 times negative 15 is what? So we have a 12, let me use this. 12 times negative 15, this is 60. This is 2, 1, 0, 180, okay? Negative 180 x squared. Negative 180 x squared, what will work? 2 and negative 90, no. Negative 2 and 90, no. 3 and negative 60, no. Negative 3 and 60, no. 4 and 16, 20. 4 and 45, right? 4 and negative 45, no. Negative 4 and 45, no. 5 and 3, 15, 30. 5 and negative 36, right? Negative 5 and negative 36. Will it work? No. Negative 5 and 36, no. 6 and negative 20. No, 6 and negative 30. 6 and negative 30, no. Negative 6 and 30, no. 7, no. 8, 2, 16, 20, no. 9 and negative 20. 9 and negative 20 will not work. Negative 9 and 20. Negative 9 and 20 is going to work, right? Because 11 plus 9 is 0, 20. Okay? So negative 9 and 20 will work. Okay? So this is 12x squared minus 9x plus 20x minus 15. All over the denominator, can we factor by GCF to simplify it first? No, because of 20, 23, 6. 23 is a prime, so we cannot. So we multiply the first and third term, that gives us 120. 120x squared. 2 and 60 will not work. Negative 2 and negative 60 will not work. 3 and 40, no. Negative 3, negative 40, no. 4 and 30, no. Negative 4, negative 30, no. 5 and 2, 10, 20. 5 and 24, right? 5 and 24, no. That's 29. Negative 5, negative 24, no. 6 and 20. 6 and 20, no. Negative 6 and 20. Negative 6 and negative 20, no. 7, no. 8. 8 and what? 8, 1, 8, 40. Yeah, 8 and 1, 8, 45. 8 and 15. 8 and 15, will not work. But negative 8, negative 15 will work. So this is 20x squared minus 8x minus 15x plus 6. Okay, so you can factor horizontal or vertical, okay? That's not a problem. I like doing my vertical, 12x squared minus 9x, 20x minus 15. What will come out here is 3x. So this is 4x minus 3. And this is 4. No, this is 5. And this is 4x minus 3. So you have 3x plus, you have 4x minus 3 and 3x plus 5. That is the numerator, okay? Then we look at the denominator. We have 20x squared minus 8x, then negative 15x plus 6. What is common here? 4x. 4x is common, and you have 5x minus 2. Then here, what is common? Negative, because remember, this is a leading negative. This is a leading negative, so you factor out the negative first. Negative 3 is common here. This is 5x minus 2. So you got what? You have 5x minus 2 and 4x minus 3. Okay, so let's finish it up. So if we finish it up, we now have 4x minus 3 times 3x plus 5 all over 5x minus 2 times 4x minus 3. So this will cross out, and the answer becomes what? 3x plus 5 over 5x minus 2. You cannot simplify anymore, so this becomes your answer. Okay? Becomes your answer. Question 5. So you have to take your time so that you make sure you get it right. And usually something will cross out. Usually it is not a hard and fast rule. It is not mandatory that something will cross out, but usually the kind of questions that I ask, something crosses out. But it is not mandatory, okay? You could still break it down and nothing will cross out. You just leave it like that. Question 5, 4x squared plus 8x all over x cubed plus 8. Okay, our numerator we can factor by GCF. Our numerator, we factor by GCF. And then denominator, we have to do difference of sum of 2 cubes. Okay? Our numerator is factored by GCF. Our denominator is sum of 2 cubes. So we have to write sum of 2 cubes. Sum of 2 cubes, if we can recall it, let me write everything here. Difference of 2 squares, x squared minus y squared is product of their sum and their difference. Okay? Difference of 2 cubes, x cubed minus y cubed is x minus y times x squared plus xy plus y squared. Sum of 2 cubes, x cubed plus y cubed, will be x plus y times x squared minus xy plus y squared. Okay, this is something we have done the videos on, so you can view it. Now, we now see that the numerator, the GCF is 4x. What is remaining? X plus 2. All over, this is x cubed plus 8. So, if we do x cubed plus 8, then we have our y to be what? Remember when we did videos on this, when we have x cubed plus 8, this means x cubed plus 2 cubed. So that means your x is your x and your y is your 2. So this will be x plus y, x plus 2 times x squared minus 2x, okay, plus 2 squared minus 2 times minus x times 2, which is 2x, then plus 2 squared. So this will cross out, x plus 2 will cross out x plus 2, and you now have 4x over x squared minus 2x plus 4. And this becomes your answer. That's it. That becomes your answer. If you think it was, with difference of with sum of 2 cubes and difference of 2 cubes, it's already simplified. So if you think you can factor this, no. Not by factoring method, no. Okay? If you want to try, you try. Then if you look at it, 4, 1 and 4, no. Negative 1, negative 4, no. 2 and 2, no. Negative 2, negative 2, no. That's all you can get. So this becomes your answer. Okay, question 6. We have 16x cubed y plus 24x squared y squared minus 16xy cubed all over 24x squared y plus 12xy squared minus 12y cubed. So when you look at question 6, you think, these are big numbers. Where do you start from? Look at it very well and see whether you can start from factoring by GCF so that you can work with simple numbers. Okay, when you factor by GCF, it makes the work easier. Okay, so let's begin with the numerator. Let's start with the numbers. 16, 24, 16. What is the GCF there? I mean, 4 can go, 6 cannot, but 8 can still go. So for the numbers, it's 8. Then x cubed x squared x is x. Y squared y cubed is y. 8xy is the GCF. What is remaining? 16 divided by 8 is 2. X cubed divided by x is what? X squared. Y divided by y is 1. Okay? Plus 24 divided by 8 is what? 3. X squared divided by x is x. Y squared divided by y is y. Minus 16 divided by 8 is what? 2. X divided by x, gone. 1. Okay. Y cubed divided by y is y squared. All over, let's get to the denominator. 24, 12, 12. The GCF for the number is 12. Then x squared x, and the other one does not have x. So there is no common factor. Okay, so we leave the x. Y squared y cubed. The GCF is y. Now what is remaining? 24 divided by 12 is what? 2. X squared divided by 1 is x squared. Then y divided by y, that's 1. Plus 12 divided by 12 is 1. X divided by 1 is x. Y squared divided by y is y. Minus 12 divided by 12 is 1. Y cubed divided by y is y squared. Okay? So you can go ahead and simplify now, see what you can cancel out. Now there's something I want to say real fast. I want to say something. This is a mistake that students usually make. Some students, when they see this, for example, maybe x plus 4y over x minus 2y, you know what they will do? They will go and cancel this, like this. So when they do this, I want to ask you a question. Can you do this 2 plus 5 over 2 minus 3? Can you do this 2 divided 2 like that? And the answer becomes 1 plus 5 over 1 minus 3, which is 6 over negative 2, which is negative 3. Can you do that? You cannot. Because you see, if you can't do it in arithmetic, what makes you think you can do it in algebra? This is an entity. when you have a plus or minus sign attached with this, you cannot do this kind of thing. You cannot. You can't just come and cross it out like that. No, because this is an entity with plus or minus. If you do this and then use PEMDAS, if you use PEMDAS, this will be 7 over negative 1, which is negative 7. But if you cross it out like this, are you going to say 6 over negative 2, which is negative 3? Now, is negative 7 equal to negative 3? No. Now, this is the way you can do it. If you have something like this, x over maybe x minus 4y over x, maybe 2 minus 4y, then you can now cross out the x. If it is multiplication, that is the only time you can cross out. You can't come and start crossing out maybe 2x squared divided by 2x squared. You can't do that. That would be wrong, okay? This is only when you have it like multiplication, like now, this is times here, and this is times. So you can go ahead, you cross out y, you can do that. Okay, you can only do that when you have times. You can't do that when you just have this, you cannot. Now for the 8, 4 can divide 8 to give you 2, 4 divide 12 to give you 3. So we have here the numerator, we have 2x. Now this is quadratic trinomial. 2x squared times negative 2y squared is negative 4x squared y squared. Okay, 1 and negative 4 will not work. Negative 1 and 4 will work. So this is 2x squared negative xy plus 4xy minus 2y squared all over 3 is remaining here. 2x squared times negative y squared is negative 2x squared y squared. 1 and negative 2 will not work, but negative 1 and 2 will work. So this is a 2x squared minus xy plus 2xy minus y squared. Okay, let's finish this up. So what will this give us now? What will it give us? We have 2x times, I like doing my radical method. So this is 2x squared minus xy. This is 4xy minus 2y squared. Then you factor by GCF. GCF here is x. This is 2x minus y. GCF here is 2y. And this will be 2x minus y. Okay? Then, so you have 2x minus y times x plus 2y. That is for the numerator. For the denominator, you have 2x squared minus xy, and you have 2xy minus y squared. GCF here is x, you have 2x minus y, and GCF here is y, and you have 2x minus y. So you have 2x minus y, and then x plus y. Okay? So let's finish this. This will give us 2x times 2x minus y times x plus 2y all over 3 times 2x minus y times x plus y. So, of course, this will cross out. And what is your final answer? 2x times x plus 2y all over 3 times x plus y. And this becomes your answer. Okay? That is it. Thank you for listening, students. We shall stop here for tonight, and in the next video we shall do part 2 of simplifying rational expressions, whereby we shall solve more challenging problems. So thank you so much for listening on New Northern.